Hey, and welcome back to another Learning Java 2D Game Programming video. So in our last video, we implemented window resizing. So now we can resize our window. We can have it in full screen mode if we want. We can have it in windowed mode and yeah, all of those things. We also refactored our UI containers. So we don't have to pass in the window size to all of them, which is very nice since we were hardly ever using it anyway. So that was a good refactor. However, it of course came with some other problems. So I'm just going to hit play. And I don't know if you can see this on YouTube since it's going to have a lower frame rate anyway, but it's not as smooth as it used to be. And there is a reason for that. So we decided not to use the sprite of our alignable container that we use in our states because it would be too much of a performance hit, because then it would make an image the same size as the entire screen, and then it would look at every pixel and be like, should I render something here? Should I render something here? Should I render something here? And doing that so many times each second would be a performance hit. So the problem is we are getting the light version of that problem anyway, even though we're not using its sprite. It's still generating its sprite, that fixed amount of times per second that we set for our UI containers. So that was an optimization that we did for our other containers, and it's worked very well. It's just that this particular one is so very large and encompasses the entire screen. So we don't want it to generate its own sprite. We're not using it anyway, and it's just taking resources. So we're gonna fix that. And the way we're gonna fix it is, not a Kotlin class, making a new Java class. And I'm gonna call it a UI canvas. So a UI canvas is essentially going to be an alignable container exactly, with the only difference that it's not going to generate its own sprite. So we're going to override the protected void generate sprite method. And we're going to do nothing inside of it. So no generating of any sprite. And it's complaining because this method isn't actually protected. It's private. So we need to pop over to the UI container class there. And here on line 86, you can see that it says private void generate sprite. So let's just change it to protected. Now this will be happy. So let's just pop over to the state and make sure that for the UI canvas, we don't use an alignable container, but instead a UI canvas, and make that a new UI canvas. Now, if we try that again, all right, so again, I don't know how much you can tell on YouTube, but it's actually much smoother. So we're back to where we were before. So that's great. Right, so what are we gonna do today? Well, I was thinking I wanna make it a little more clear when a person is coughing, because currently it's quite hard to tell, actually. It's a little unnecessarily hard to tell. So what I think we're gonna do is we're gonna have some sort of a visual spawn from them when they cough. And originally I thought it would be cool to have like some sort of cloud, but it turned out they were very hard to make art for. So I'm not gonna have a real cloud. We're gonna use the star character. And it's gonna sort of have to double like sort of a cloud or some sort of particle. And it's gonna be okay for our little tutorial game. So we're gonna make some sort of coughing visual that is a star character. So let's get to that. So the first thing that I'm gonna do is I'm actually gonna make sure that my window, is not full screen. So I want to be able to move my window around, look at code, close it down if I want to. So I'm going to remove that set size to the screen size and set undecorated true. So we're going to be back at where we were. All right. And then I'm going to head over to the entity package and create a new class, and I'm going to call it a cough particle. And it's not going to be a particle like in a particle system. So maybe we can do something like that in the future, but right now we don't have a need for a system that advanced. So let's just make a specific cough particle. This is a game object, so let's implement the methods. So what do we need in our cough particle? Well, we need to store the sprites. We need some start position. We need a vector that I'm going to call the move direction, which isn't entirely true. It's not just a direction. This is actually the entire path that I want to move. So I'm just going to say move path. All right. It's going to have a lifespan in updates. And we're going to also have to keep track of how many updates we've been alive. All right, so Alt insert and make that constructor. We're only going to take in the start position. All right, so after we done that, we're going to make the sprite, and we're going to do it like sprite is equal to. So let's use our UI text because it already contains all the logic for generating an image from a string. So I'm just going to give it a start, and then I'm going to say get sprite. But this isn't going to work entirely out of the box. So let's pop over to the UI text. And the reason for that is we need to create the font and calculate the size. And it does that on the first or on every update, but it doesn't do it until it updates. And here we have not updated yet. So we're actually going to do it inside of the constructor as well, so that it has initialized everything at least once. So that will make this getSprite work as it should. And then I'm going to set some of the regular stuff that we need to set. So a size, and we can use the sprite here. It wants some position, and I'm going to start by saying that it's the start position. Some sort of render offset. And I'm going to make that so half the width and the entire height. So this is probably something that we're going to do quite a lot with stuff. Center it on the width and move it up by the entire height. So basically that would mean the same thing as its origins or its position being at its feet or at its base. So that's what we're doing. I'm going to say lifespan in updates. Each cough particle will live for 1 second. I'm going to say move path is a new vector 2D, and it's not going to move anything in the X direction, at least not to start with. We'll fix that later. We'll just move it in the Y direction for now to see that it works. All right, so then what do we want to do? Well, and before we do this, we obviously need to tick our updates alive up one. So increment updates alive, and then we can check. If updates alive is smaller than lifespan in updates, then we are still alive. We should still update ourselves. So we should update our position. I'm gonna make a method. And if our updates alive is not smaller than lifespan, then we have expired. So I'm gonna say state despawn this. So let's generate the update position method. And what I'm going to do is I'm going to start by calculating the current time. Like how long have we been alive compared to how long are we going to be alive. So basically updates alive divided by lifespan in updates. And now they are both int, so we need to cast one of them. Good. Now we can calculate a new position. So the new position will be start position get x plus move path get x times current time. All right, and then I'm just gonna duplicate that and say y for both. So basically we are moving linearly on this move path. So that should work. In the get sprite, let's return the sprites. In the collision box, let's just say collision box of position and size. So hopefully this works. Let's use it, and we will use it inside of the cough action. So here, when we update, when we cough, I'm gonna say if state gets time seconds dividable by 0.5. So every half second, let's spawn cough particles. And we probably need both the states and the performer there, actually. All right, let's generate that method. So first we need a starting position for our particles. So I'm going to say position, start position is equal to position dot copy of performer get position. And I do this because I want to be able to subtract a new position. I'm going to say 0 and 20. So this is just to move the start position up a bit from the performer's position, which is at its feet, right? All right, so we have a start position. Now let's do state spawn new cough particle. I'm going to give it this start position. I'm just going to have one for now. So let's try this out. Let's see if something's happening. All right, did you see that? Ooh. Did you see? See, when they cough, these are popping out. That's great, but they don't look very fun at the moment, right? They're looking a little sad. So let's fix that. So the first thing that we're gonna do is we're gonna give them a random direction on some angle so that they don't move straight up. And then let's make more of them. So to make them get a random angle, just gonna pop over to the cough particle, and I'm gonna say something like, let's try this. Move path, rotate by degrees. And then let's make, first of all, math.random times, and I'm going to say 180, so half a circle. But then we need to move it back half of that. Otherwise it will start from north and then go half a circle like this, and that's not what I want. I want the circle to be like so. All right, so this is how we're going to do it. So we need to implement rotate by degrees inside of here. And I'm just gonna look at my notes. So that's gonna look like this. First, we need the radians. And that's gonna be degrees times, actually, I think there's a helper method inside the math, right? 2 radians. Okay, much better. So math 2 radians degrees. And now this I have Googled. I don't know this in my head. So the cosine angle is math.cosine of radians. And then the sine angle, math.sine radians. Oop. And now let's make rotated x is equal to the cosine angle times x minus the sine angle times y. And the rotated y is the sine angle times x plus the cosine angle times y. And then when we've made these calculations, we set x to the rotated x and y to the rotated y. So now this will rotate a vector for us by this amount of degrees. So EA for that. All right, so now we have rotated it and that should be good. I'm just gonna go in here, and when we spawn particles, I'm just gonna make a quick little loop. I is less than 4. And move this up so that we get, I guess, 4 particles, and hopefully they all get random random angles. Oh, did you see? Already someone was coughing. Hello, Mr. Cougher. Cough some more, please. I promise I won't isolate you for now. Ooh, more coughers. All right, so as you can see, it's working and they are getting random directions and everything. So I'm quite happy about that. However, it's a little sad that they're just moving out linearly. It would be fun with like an ease out effect. So let's make an ease out effect. And the way that is gonna look, I'm gonna go to the cough particle and put it in here right now. We can move it later if we want to move it in several, or if we want to use it in several places. I'm just gonna call this quadratic ease out. Gonna move this a little. I think it's not in the right place. All right, so that is gonna need some start value and some end value, I guess. No, that's not entirely true. It's the difference, so the amount that we are changing this value. All right, so first we need that current time. I guess we could just actually steal this. So we need this time, and then we're going to return the inverse of the difference times current time times current time minus 2 plus start value. So this means that we don't need this. Instead, we're going to use the quadratic ease out. So I'm going to say quadratic ease out. It needs a start value, which on the x will be the start position get x, and a difference, which will be the move path get x. And then I'm just going to remove that and duplicate the line above and change to y. All right, so let's see how this looks. Also, I totally Googled this ease out function. Yes. Did not know that. Let's see. It's always good to move down here. There are a lot more people down here usually. Cough again, please. All right. I don't know if you could see it down here, but it is working. It is easing out quadratically, but it looks much more interesting than just the linear ease out. So I'm very happy about this, I think. Maybe even too happy. Now it's very easy to tell when people are coughing. So in the next video, I think that we will be looking at changing how the gameplay works a little bit. I think that maybe we actually want a timer instead, counting down, and then you lose if you haven't found all of the sick people in time. And we might even want some sort of score, so we could have a score if you isolate, you can get points if you isolate the sick people, and maybe you can even get some sort of penalty if you isolate healthy people, just to make it a little harder, so it's actually a bit challenging to play. But yeah, now you can totally see when people are coughing, and we might even dial it down a bit. We'll see. But this will be all for this video, so thank you so much for watching, and I will see you soon. Hej då!